You know, right now, as you're listening to this, you are not alone. Not even close. There's an entire living world on your screen, in the air you're breathing, and yeah, even on your skin. A world that's been completely invisible for pretty much all of human history. Today, we're gonna make it visible. Seriously, just think about that for a second. What if you could see the trillions of tiny organisms crawling on your hands or just swirling around in the air? How would that change your whole perspective on everything? It's a reality that honestly we've only just started to get our heads around. For almost all of time, this microscopic world was a total secret. We were surrounded by a universe of life we had absolutely no idea even existed. So how on earth did we finally pull back the curtain? Well, it all started with something surprisingly simple, a piece of curved glass. And get this, it was often shaped just like a lentil seed, which, believe it or not, is where we get the word lens. This one simple tool and its power to bend light and make things bigger was the very first step. And that simple tool kicked off a quiet little race back in the 17th century. Over in England, you had this brilliant mind, Robert Hooke. At the exact same time in the Netherlands, there was a fabric merchant named Antony van Leeuwenhoek who was, well, he was obsessed with grinding lenses that were way, way better than anything else at the time. They were both racing to be the first to really explore this new, invisible frontier. So one day, Robert Hooke points his microscope at a tiny sliver of cork, and he sees something incredible. It wasn't just a solid piece of material. It was a neat, orderly pattern of tiny, empty boxes. They reminded him of the small rooms, the cells, that monks slept in. And just like that, boom, the fundamental building block of all life had a name. Okay, so Hooke gave us the word. But what is a cell, really? Well, it turns out it's the most basic building block for every single living thing we have ever discovered. And that brick wall analogy is just perfect. Think about it, right? You can't build a house with just one brick. In the same way, you can't build a giant oak tree, or you, from a single cell. Life uses these tiny functional units, stacking them together by the billions and trillions to create, well, us. Each one is like its own little factory, a tiny living machine. But here's the cool part. Not all of these bricks are the same. A plant cell, for example, needs to be really sturdy to help the plant stand up tall. So it's got a tough outer wall. An animal cell, like ours, needs to be flexible. And since plants make their own food, their cells have these amazing little green solar panels inside called chloroplasts. Our cells, yeah, we can't do that. It just goes to show you, at this tiny scale, how something is built is all about what it needs to do. Okay, I want you to look at this number. 170 millimeters. That is almost 7 inches. What in the world could possibly be that big and yet still fit our definition of a single cell? You're not going to believe it. It's the yolk of an ostrich egg. Yep, that entire golden sphere is one single gigantic cell. It's a wild reminder that these building blocks of life come in all sorts of sizes, from something totally microscopic to something you can literally cook for breakfast. All right, so we've got the cell as a building block, but what about organisms where the entire creature is the block? Now let's meet the true tiny titans of our world, the microorganisms. So, as the name suggests, these things are on a microscale. They're so incredibly small that a single drop of pond water or just a little pinch of soil can hold a bustling city of millions of them. They are the true rulers of our planet, covering every single surface in an invisible, living layer. And the diversity is just insane. That single drop of water isn't just water. It's a whole ecosystem. You've got little hunters like amoeba swimming around looking for food. You've got tiny algae acting like microscopic plants. And in the soil right under your feet, you have fungi breaking things down and bacteria performing all these amazing chemical miracles. It is a hidden, bustling metropolis down there. So they're everywhere. But this isn't just some random trivia. No. These tiny titans are absolutely essential partners in our daily lives, from the food we eat all the way to the health of the planet itself. I mean, if you've ever baked bread, you've actually been a microbe farmer. That yeast we add, that's a living fungus. And when you mix it into the dough, it starts feasting on all that sugar. And just like us, it breathes. It exhales these tiny bubbles of carbon dioxide gas, which get trapped in the dough, puffing it up like millions of tiny balloons. That's what gives bread that light, airy texture. And their work goes so far beyond the kitchen. Microbes are the planet's master recyclers. They're the cleanup crew. They decompose all the dead plants and animals, turning all that waste back into vital nutrients for the soil. We've even learned to put them to work for our own messes, like engineering bacteria that can literally eat oil spills. Without them, the planet would just grind to a halt under its own garbage.
Our menu would be so boring without them. That tanginess in your yogurt, that comes from lactobacillus bacteria fermenting milk. The delicious sour flavor of an idli or dosa, that's bacteria too. But they're not just in our food, they actually help grow it. Bacteria like Rhizobium live on plant roots, grabbing essential nitrogen right out of the air and feeding it to the plant. It's like a built-in natural fertilizer. And our relationship with them is still changing. We're now farming tiny microalgae like spirulina and eating it directly as a superfood. It is packed with more protein than steak. So let's add it up. We eat them, they help grow our food, and oh yeah, microbial life in the oceans is busy producing more than half of the oxygen we're breathing right this second.
Which brings us to a final, really critical question. We've seen that these invisible organisms aren't just curiosities. They are the architects of our food, the janitors of our planet, and the source of the very air we breathe. So what would happen if they all just disappeared? It really makes you realize the biggest things keeping our world alive are often the things that are too small to see.